Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. We have been doing this for many years, and previously it was done under the Electrical Guru. Boy, I took some flack for that, because you got haters everywhere. But at the end of the day, we've been doing these things for God. I remember the first podcast I did was well before the podcasts were even known. This was under 1,000 mics, used to be the platform, and God, I was back in Richmond, Virginia, even before then, that I was doing these and putting them online and using only that platform because there was no way to deliver anything. And I had listeners way back then who have now gone on to do their own podcasts, and kind of neat to watch them grow. And so we've been doing this for many, many, many years, many code cycles. And so I do a lot of topics, and sometimes I'll elaborate on some topics even more. And grounding and bonding seems to be one of the topics that I get a lot of questions about. I do a lot of presentations on it. Different associations want me to come out and do grounding and bonding training, a full day training, and I enjoy doing it. It's one of the better presentations that I like to do. I love grounding and bonding and the concepts of it, and it always is scratching my head with it. I serve on Codeman Panel 5, and again, that was a pure treat to deal with those individuals, because there are some extremely sharp individuals on that code panel. Maybe not on all code panels, but that one, man, I highly respect everybody on that panel. And so being involved with them, racking the brain, sitting back and watching them and taking a lot of this stuff in. Some are more active than others, and it really helps you give you a full grasp of it. So when I'm asked to teach grounding and bonding all over the place, I like to focus on certain things that I find that people still have questions about or really don't understand. And one of those happens to be bonding at the services. Believe it or not, still is an issue that people kind of struggle with. What do I have to do at a service? What do I have to think about at a service? We take it for granted. And so today's topic, we're going to talk a little bit about it. And again, I'm going to try to paint you a visual picture because, again, podcasts don't always have the nature of you having your code book with you. But I enjoy presenting them and trying to portray it in a way that you can understand it while you're riding down the road or sitting on a job site, or maybe you're around your morning break and you're playing it to all your electricians there, and y'all are listening to it and pause it to have a discussion when I say something. And I've had people do that. Maybe it's part of your morning briefing or whatever it might be. So we're going to talk services, and we're going to be firmly in part 5, dealing with bonding of Article 250. And we're going to be generally talking out of the 2017 code. I've not switched gears to the 2020 yet. It is not out yet. And so even though I'm on a code panel and I can see things behind the scenes in TerraView, and I have talked about code changes, I'm not ready to shift full gears when it comes to grounding and bonding totally yet. So we're going to talk about the 2017 code. Now, we're at part 5, and we're talking bonding. The general rule for bonding, and we're going to talk about it, it's 250.90. And it says, bonding shall be provided where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed on it. That means you got to do it right. That means you have to make sure that all these connections are done adequately with proper equipment and done in a proper manner. And so a lot of times we take things for granted. Don't put the lock nuts on right. We don't do bonding bushings right. We kind of don't. We just put them on and we take it for granted. We don't clean the metal off to make a good metal-to-metal connection if it's relying on that connection. We do a lot of things. And grounding and bonding is one of those things where set screws have to be done right on raceways for conduits and tubing and all this kind of stuff. We need to make sure that we do those connectors right, we do those couplings right. All this stuff matters, right? So we're going to talk services today. And we're going to look at 250.92, and we're going to talk about trying to bond equipment that is associated with the service. and kind of get a better detailed understanding of what's expected of you. All right, so moving into 250.92 services, and that's what it's titled, we're dealing with A. Now, when you think about services, you got to think that we're going to do something extra, right? I mean, it's a service. First thing we know that in the service, all of the bonding that takes place for service conductors has no real overcurrent protection upstream. Okay, it's got a limited amount of overload protection based on the breaker that those service conductors are terminating into. So they're only going to allow so much current to get through based on the rating of that. So we have a little bit of overload protection, but we really don't have any short circuit or ground fault protection except for what we might have on the primary side of the utility transformer. And we really don't know what it is. We don't have anything to do with it. We're just assuming it's there. So we're going to make all of this connections that have service conductors in it, or any type of enclosure that encompasses service conductors. We're going to make sure that we do something that's ensured that it can carry that fault current, in the hopes that something upstream might limit the fault current. Okay? We're not going to worry about it. We're not going to dwell on it. We're just going to make sure it happens. We're not going to let our head get wrapped around what somebody might do on the primary side. Because I can tell you, you look up at a transformer, very rarely do you ever have anything on the secondary side. So let's kind of move with that. So we're talking about services, whether it's a panel board, switchgear, whatever it is. So A says this, 250.92A, if you're in your 2017 softbound and you want to follow along, we're on page 117. If you're in the PDF version, I don't necessarily know what page it is, because today I'm not using the computer. I'm just using the actual softbound edition of the 2017 NEC. All right, here's what it says. For A, it says bonding of equipment for services. It says the normally non-current carrying metal parts of equipment indicated in 250.92A1 and A2 shall be bonded together. So all we're doing is bonding things together here, right? Makes sense? We're just bonding everything together and making sure it's all theoretically at the same potential. We're just trying to tie it all together. All right, what are those things? Well, A1 says this: all raceways, cable trays, cable bus framework, auxiliary gutters, or service cable armor or sheathing that encloses, contain, or support service conductors, except as permitted in 250.80. Well, I will tell you that 250.80, which incidentally is kind of located on the same page, at least part of it, top left of the page, you'll notice that there is an allowance that says, you know what, I'm gonna have to bond all these things together when connected to a grounded system. But there's an exception that says, you know what about that elbow that is metal, that is covered up by 18 inches of cover? Well, it's not like I can bond that. Okay? It's not like I can make a connection to it. So it's not required to be connected to the grounded system conductor or the supply side jumper or the grounding electroconductor. So it's not. It's 18 inches in the ground. When would you do this? Usually when there's a pull and they're putting PVC, but they get to elbows and they change over to metal, and provided they do that properly, when they change over, it keeps from burning out the inside of the bend when you're pulling it due to friction, because PVC, when it's pulled in friction, it could cause the friction could heat up and cause you to damage the elbow, whereas they put the metal and you don't have that. So a lot of people will put the metal elbows in, but there's no way you can bond those, and they could, obviously if they're underground and they're for the service, they got service conductors in them. There's no way you're going to do that. So that's what it's talking about in the allowance in 250.80 for you to not have to bond that piece. It'd be kind of hard to do. And I can't imagine running a conductor out and trying to make a connection to that underground. And if you do touch it, you shouldn't be digging it up and messing with it. I'm just saying. Anyway, so that's what we're talking about, except as permitted in 250.80. Now, the second thing bond together, it says 2. All enclosures that contain service conductors, including meter fittings, boxes, and the like, interposed in the service raceway or armor. When we say interposed, means it just gets in the way. So I'm going from a weatherhead down a raceway through a meter enclosure onto the service disconnect into the service equipment, that meter enclosure is just getting in the way. It is being interposed into that service conductor run. But we still have to bond that meter enclosure. And other people ask me, but what about a CT cabinet? Absolutely. Still has to be bonded. The good news is we can use the neutral conductor to make that connection and bond it on the supply side as well. So the code gives us that provision to do that. But it still has to be done because it does contain service conductors. All right, so we kind of understand now all the things that have to be, basically if there's service conductors in it, right, and there's service conductors that are enclosed in it, then all that equipment has to all be bonded together. You basically keep it all at the same potential. Some people might not like that concept, but that's what you're doing. You're making sure they're all tied together and they're all intimately connected together. Now, we're getting at the service now, and now we're going to get to B, because we know what we have to bond together. It says methods of bonding at the service. So we dealt with bonding of equipment for service. Now we're going to talk about the methods of bonding at the service. And here's what the code says. Bonding jumpers meeting the requirements in this article shall be used around impaired connections, such as reducing washers or oversized concentric or eccentric knockouts, okay? Standard lock nuts or bushings, that's standard bushings, not bonding bushings, shall not be the only means for bonding requirement for this section, but shall be permitted to be installed to make a mechanical connection of the raceway. Okay, so let's kind of break that down. You can't use a standard lock nut or standard bushing even if you put it on there nice and tight. You can't do it because a standard lock nut wasn't evaluated for it. So I have to do something else. Okay, I have to go over and above because you could have some kind of impairment. In another video I did that previous to this, I talked about supply side bonding jumpers in an open bottom enclosure. Well, that's an impairment because it's not physically connected to the enclosure, period. So in that case, it needed a bonding jumper connected to all those raceways. They were metal raceways, and you need to bond them because they contain service conductors. We're meeting all the rules of 250.92a for all the equipment that's associated. Now we're in B, and it's going to tell us how to do this. Okay? All right, so we know we can't use a standard lock nut. Now, I get people ask me, as I go down this list, they're going to say, well, Paul, in this list says that I can use a threadless coupling and connector made up tight for metal raceways and metal clad cables. Absolutely you can. That's to connect the raceway or to the tubing. It has nothing to do with the requirement of connecting it to the enclosure. Okay, just because it's a fitting with a flat throat on it and it connects to the enclosure and then you put a standard lock nut behind it, that is different. It's saying that you can use it to bond all these raceways together, and a connector to the raceway is fine. But then you got to make that connection to the actual enclosure, and a standard lock nut is not going to do that because it can work loose. All right? So we'll go into this in a little more detail, but I do get people that confuse that. In fact, I just did a seminar for the IAI chapter down in Florida. Great bunch of guys down there for King Castronova and his group down in Fort Lauderdale. And it's a great class, and one of the guys said, well, you mean I can't use an EMT fitting to make that connection because it is a threadless coupling connector? And I said, yes, you can use it to connect to the raceway that contains them. So you're bonding the connector to the raceway, and I could use couplings for raceway to raceway bonding that contains those conductors. But once you go to the enclosure, you cannot use the standard lock nut to assure that connection is made. Okay? Two different things. Now, people can agree to disagree because they say that the lock nut is only being used mechanically to hold it there. I disagree. Okay? I personally believe that most of the enclosures you get are enameled, and so that throat's not going to make a good connection with enamel, so you need to have a lock nut that can bite into it or that's rated for this application. And that's where you would need, if you had no concentric or eccentrics and just a popped hole or a bored hole or a plugged hole, then you could use a bonding lock nut because that has the lock nut features but it also has the screw that drives down into the metal and makes that connection onto the threads. Okay, but I don't believe, to me, my opinion is that there's two different things going on here, and I do not believe that that lock nut, standard lock nut, because of what it says in the charging statement, meets that requirement. Okay, I don't, because it can work loose, and if it works loose, then that connection from the throat or the sleeve of that connector to the enclosure can come loose. Okay, it's not what we call assured or insured bonding, that it's going to stay there and remain intact, and that's what I'm talking about. Okay, all right, so let's go back to the list, because I don't want to get away from the list. All right, now it goes on to say you can't use a standard lock nut. Now here's what it says. It says electrical continuity at service equipment, service raceways, and service conductor enclosures, okay, shall be insured. ENSURED, okay, by one of the following, with the understanding that the standard lock nuts or bonding bushings can't serve that role to connect to that enclosure. It might connect the connector to the raceway, because they're all pieces, they're all components, and they all get connected together. Okay, but that connection at the enclosure is where I have to take it to the next level, and it has to be insured. So let's kind of read down through these. All right, and it has to be one of these following methods. So the first one says bonding equipment to a grounded service conductor in a manner provided in 250.8. Okay, so I can take a bonded equipment and take it over to the grounded conductor as long as I'm meeting a connection method or termination method that's in 250.8. And 250.8 has a long list of what we can use. Okay, self-tapping screw, as long as it engages 2 full threads, all these kind of methods that you can use, certain lugs, binding devices, all those type of methods are listed in 250.8, and they're there for a reason. So it's just saying, look, if I make a connection from that equipment over to the grounded, okay, make that over to the grounded service conductor, then I'm good to go. So that's what we do in meter sockets, meter enclosures, I should say. That's what we do in CTs for the most part, to keep it simple. Because a lot of times people want to run something back from the equipment over into the CT, and you already have a grounded conductor going in there, then you can create parallel paths. And you already got, if you use a metal raceway between them, you already got a parallel path potentially. But we really kind of don't say anything about that. But if you put another conductor through there to run to some kind of lug over in the CT or meter, then you're creating yet another path, and that kind of creates a problem, but we're kind of hush-hush on that. That's why I'm also a big fan of PVC. Eliminates all of that potential parallel paths. But anyway, I don't want to digress. So I could do that as long as I make the connection to the grounded conductor. And that's done in a lot of places that we do that, okay? And it's not only mentioned here, okay, in 250.92B1. It's not just mentioned there. Okay, if you go and look at 250.142, for example, then you'll see where it specifically gives permission on the supply side to use the grounded conductor to bond. So it gives you a list, 1, 2, 3, and it tells you when we can use the grounded conductor to bond on the supply side. So that's one of the more common applications where we might use a grounded conductor to make a connection on the supply side in order to be able to bond. And again, one of the allowances here says I can bond the equipment to the grounded conductor, service conductor, in a manner that meets 250.8. And so then the next one, because we use that grounded conductor for the application, again, on the line side or supply side, not on the load side. Now, there's some exceptions to that rule in 250.32B for existing applications and for applications in, I said 250.32B, excuse me. In 250, I believe 142 might allow that. I'm not 100% sure if it's 142. Yeah, 142B, and some of the exceptions to that when you're dealing with ranges and ovens and all that might be existing. But other than that, typically you're using the neutral on the supply side, okay, to do that. And it saves you a lot of labor if I've got a CT cabinet or I got a big piece of equipment that I have the conductors coming in. I just take that neutral and do the jumper over to it. That's a supply side bonding jumper. It's not a main bonding jumper because that's over in the service equipment. okay, where the grounding electroconductor, where the grounding conductor, and all those come together and you're bonding the enclosure. But it is a supply side bonding jumper. And so I would size it the same way I did it in the previous video based on the conductors that are supplying that enclosure. And then I size it accordingly in 250-102C1. All right, so we're going to move on to item 2. Now, item 2 says, we're dealing with, again, bonding at surfaces. It says connections utilizing threaded couplings. So that means raceway to raceway. And it's threaded, so it's rigid or IMC. Or threaded hubs on enclosures if made up wrench tight. So that might be a Myers hub. That might be a built-in hub with the 4 screws you see on top of a meter, for example, where the raceway threads down into it. And that makes a positive connection, has 4 screws, and that is made through tapped thread, so it's a threaded screw. Everything gets bonded together pretty well. Again, we're talking bonding. And so I can connect that raceway threaded through a hub to the enclosure, and that's it. And remember, I'm not jumping anything over to the grounded conductor at this point. I'm just bonding one raceway to an enclosure, and that's how I'm doing it. All right? So that's just the simpleness of bonding. Remember, we're talking bonding. All right, now the third way, as I kind of alluded to, was threadless couplings and connectors if made up tight for metal raceways and metal-clad cables. So that's the connectors that connect together. That is the couplings that connect two together, typically for the a raceway. In the cable, it's continuous, so you're just having connectors that connect the two enclosures. But that's to connect the cable assembly to the connector, which ultimately gets connected to the enclosure. Same way with the raceway, from the couplings is raceway to raceway, and then that raceway to the connector, which connects to the enclosure. Then we have to do something that I believe needs to be ensured that it makes the connection to the enclosure, and I don't believe that a standard lock nut is insured and reliable enough. Yes, the coupling to the raceway is fine, and from raceway to raceway with a coupling or connector from a connector to the raceway is fine. When you make the connection, I don't care. We can agree to disagree on this. We'll let your inspector be the judge. But I believe that you have to do something little bit more other than simply a connection using a standard lock nut to hold on that connector. Okay. Now, the next one would be 4. It says other listed devices such as bonding type lock nuts, bushings, or bushings with bonding jumpers. So I have other means to make this connection. One of the things to remember, I can use a bonding type lock nut if I don't have any impairments. So if it's just a punched hole or I remove all the concentric or eccentric knockouts, then I would simply use a bonding type lock nut. Use a standard lock nut with a screw goes through it. It binds down into the threads. It makes a good connection and all is insured and reliable. The other is a bushing. Now I have a bushing. Some are designed for this application and they listed for it, and they go on and they actually make the connection to the actual raceway the same way. Again, you're bonding that raceway, okay, to the enclosure. If there's an impairment of any means, then I'm going to have one with a bonding bushing on it. But if there's no impairment, then I can get away with it and be able to use this. And then, of course, one of the other methods that people use is a bonding wedge. Now, bonding wedge looks like a C, has a gap in it. And that's designed that if by chance you've already installed everything and you put a bushing on there because your conductors are 4 gauge and larger and you have to meet the issue where you don't want to have abrasion as it comes out of the fitting, out of the throat into the equipment, then you're going to have a bushing on there with an insulated throat. Well, say you do all this and now the inspector says, no, I've got to have some additional insured bonding because you're using standard lock nuts. Okay, well, you loosen the standard lock nut, you get the bonding bushing in there, and you put it in there between the enclosure and the standard lock nut. The standard lock nut is just there for mechanical means, but you put this bonding, it'll slide over top of the conductors and it saves your day. The only difference is if all of the knockouts are out of it, it's just a perfectly punched hole, then I can use that, put that in, and then that makes the connection, and then it has a bigger surface area, and then I screw the standard lock nut against it, and then put my bushing on it, and I'm good to go. If you're still dealing with concentric or eccentrics, and I put this bonding wedge on it, then I'm still going to have a bonding jumper. And usually those bonding wedge has the provisions to be able to add a lug to it and be able to put a bonding jumper on that if necessary, because again, we're talking about impaired connections, and it is a concentric or eccentric or oversized or reducing washers and whatever it might be, then you have it. Now, they do make reducing washers that are listed grounding and bonding that would not require a jumper, but you got to look at the listing. Okay, standard reducing washers or oversized washers probably are going to still be an impairment, and you're going to have a bonding jumper. So just kind of play it by ear as you move through those rules. So you have a bunch of options. A Myers hub, for example, coming in the top because, again, it's maybe in a wet location and you're transitioning into the top of a piece of equipment. And maybe that equipment follows under 312 where it says if you're above or over live parts, then you have to maintain the rating of that enclosure and the raceway coming in. So you have to have something that does not degrade the rating of the enclosure. And maybe you're using a Myers hub. The Myers hubs are designed under grounding and bonding, and the way they make a connection with their serration of their bonding actually make the connection. Okay, so just look at your equipment, look at the type of fittings that you're using. Again, I will have people that disagree and say that a threadless connector for EMT is perfectly fine to a service enclosure. I'm going to disagree with you. I'm going to say that it is fine to make the connection to the raceway or the tubing that's coming to the actual, which is a raceway, by the way, that's coming to the enclosure, but I don't believe a standard lock nut on the inside is capable of making sure that that throat that's flat touches and stays in good contact with the actual metal. I think there's something else that needs to be done, and that's just my opinion. You can agree to disagree. You can call me stupid all you want. That's fine. I know how I'm going to do my systems, and I serve on Code Panel 5, and I can tell you that's the predominant thought running down there. And if you disagree, fine. Do it however you want to, and just hope that you pass inspection. All I do want to say that is if that lock nut does come loose, then you've lost your connection. If I put a bonding lock nut on it, or I put a bonding bushing with a jumper on it, then I know that even if that connection comes loose and that connector pulls away, that I am still going to make sure that that raceway and that connection to the equipment is intact. It is insured. Okay? I'm not relying on a standard lock nut. If that logic doesn't tell you how this is supposed to read, then I can't help you, my friend. Anyway, so there you go. If you're dealing with services, that's how it applies. You have a bunch of options. Just make sure you stop, slow down, take a breath, and read all the options that you have here. Again, in the charging statement, standard lock nuts are not to be used. Standard bushings are not to be used in order to make that insured bonding around impaired applications or in general. Okay, and if you do have it impaired, then you're going to have a bonding jumper. Okay, so any other questions? And I won't get into going when you're dealing with the next option, which is what if I'm dealing with applications where I'm bonding we're over 250 volts, because that's not necessarily service at that point. That's probably dealing with feeder applications and branch applications where you might have something that's over 250 volts to ground. Okay, 277, 480 applications. Then you either have the knockouts, if they're concentric or eccentric, if they're rated for 250 volts or more, then I don't have to do anything. I can use the standard fitting that's rated for that. I don't have to do anything else. However, if they are not, and I encounter that situation, I still have to meet the same kind of insured provisions. So I'm going to follow the same rules that we talked about in 250.92b, but I can't use B1. And that was a direct connection to the grounded conductor, because we're probably on the load side at this point, and that would be an improper case to neutral, and that would be a problem in 250.24a5, and we don't want to create those kind of problems, my friends. We don't. So that's why you're not allowed to do that. But we do have some exceptions under that you can read. We're not going to go into those, but there's some options there for you to make that connection. But most of the boxes that I see that's used in 277, 480 volt applications that have the knockouts in it, they're designed in a specific way that they're rated for this over 250 volt application. Okay, they're specifically in a way that they don't easily pop out, or if you over tighten a lock nut or do something that they start to work loose, and they're made a little bit different. But you can look at your enclosure, you can look at your box, and they'll tell you whether or not they're rated for that. And if they're not, then you got to follow one of the options that are in 250-92B, except the use of the grounded conductor, as we talked about. You got all the other methods to use. Okay. Anyway, that's kind of a synopsis of that one. And of course, there's some exceptions to that rule that you can follow. Again, it's on the load side. So we can use standard lock nuts on the load side to do a lot of good things. So just read the list and you'll get a better understanding of how you work it. Can't cover everything in this podcast. So hopefully you got something out of it. Didn't get you confused. If you have any questions, like always, visit us at Master the NEC. There's a contact us button there. Send me your questions. If you got a podcast you want to hear about, or some kind of video you might want to see. I do way more podcasts than I do videos because videos take a lot of time. And I am always on the roll, and I've got so much stuff going on. But I know people love the videos, and I will try to do as many as I can. But there's a lot of videos on our website and on our youtube.com/Master the NEC. So go to that and watch those videos. There's tons of them. Just scroll through them. They go all the way back into 2017. So there's a couple hundred of them there on any given topic. And if there's something you don't like, then just don't listen to it or don't watch it. I'm not twisting your arm. You know what I'm saying? So anyway, thanks, guys. Hopefully you got something out of this. Till next time, stay safe. You can email me at info@masterthenec. I'll get your question and we'll try to answer your question. And also, if you need courses, you want to learn more about residential, more about commercial, you're preparing for an exam, go to our website. We've got 5 new courses that are listed on our website that you have access to them for 365 days. You can print anything you want out of the course, any of the forms, the cheat sheets, the tables, the pages, do whatever you want. Print the whole book if you want. All available from the website. So for more information on those, visit the website at masterthenec.com or electricalcodeacademy.com. More than happy to answer any questions on that. So until next time, stay safe and God bless.
Every day, the future's getting closer. Every day, the future's looking bright.